This is Dr. Popelka Brown with your video hint for your weekly project this week. And all of the graphs you're going to be matching up have to do with the same two variables. You've got time over here on the x-axis and distance from home on the y-axis. Distance from home is on the y because it's your dependent variable, because of course the longer you travel, your time, the farther away from home you're going to be. So your distance depends on your time, and your dependent variable always goes on the y-axis. And there are going to be several different shapes of graphs that are going to be on your weekly project. So I'm going to talk to you about one of the shapes, which is right here on the graph, where your coordinates line up in a straight line. And I'm going to help you to make sure that you understand what that straight line really means. I'm going to start by looking, actually, no, I'm not going to look at that coordinate. I am going to look at that coordinate right there. And if I'm reading my graph correctly, I can see that, let's say, because this hasn't really given us a label, I'm just going to say our time for right now is seconds, and that our distance is feet, since it hasn't given us anything in particular. And if I'm reading my graph correctly, I can see that because it lines up with the 1 on the x-axis, I've traveled for 1 second, and because it lines up with the 2 on the y-axis, I've traveled 2 feet. Hopefully we remember from 7th grade that you put your y value on the top. When you were doing proportional relationships, you guys learned in a constant proportionality and all that, that the y goes on the top. So that means that I've traveled 2 feet after 1 second. So it basically took me 1 second to travel 2 feet. Let me look at another coordinate right here. And it shows me that after 2 seconds, I have traveled 4 feet. So I'm going to write another rate. Remember, a rate is when you're just comparing two amounts. In this case, it happens to be feet and seconds. So I traveled 4 feet in 2 seconds. And let's just look at one more, just to really hit it home. After traveling 3 seconds, I have gone 6 feet. So that'll be 6 feet, I'm going to start abbreviating now, in 3 seconds. So I can see that all of these actually simplify to the same thing, right? Because if I go 2 feet in 1 second, so that just means basically that I've gone 2 feet per 1 second. Well, 4 feet in 2 seconds still simplifies to 2 over 1. So it's still the same distance that I had there. And then 6 feet over 3 seconds also simplifies to a 2 over 1. So that means as I'm biking or driving or whatever it is I'm doing to travel this distance, I'm going at the same speed. That speed is 2 feet for every 1 second. And I can also tell that I'm traveling at the same speed the entire time because I have a straight line. Hopefully we remember from 7th grade our word that our speed is constant. And the reason we know that is because it's a straight line, which the big boy word for that is linear, which means that we are traveling at a constant speed. So anytime you see a distance time graph that has a straight line, that means that your actual speed is the same throughout the course of whatever trip it is that you're making. Now compare that last graph I just did to a new one. So before it was going in a straight line. This time it is not linear because I've kind of got a little bit of a curve to it. I don't know what is wrong with me today. Why I cannot write. Okay, so this is not a straight line, which if I recall from 7th grade, I should automatically know that that means that whether I'm driving or walking or whatever, I'm not doing it at the same speed or the same rate every single time. But I'm going to prove it by using some math by looking at a couple of these points. So let's look right here at this point. So it tells me, and let's just keep calling this seconds and calling this feet, just because. So after I've traveled for 1 second, I've traveled 2 feet. So 2 feet in 1 second. But let's look at another coordinate right here. So after 2 seconds, I've traveled 6 feet. So 6 feet in 2 seconds. So this time, it's not going to reduce to the same thing. 2 over 1, of course, is still 2 over 1, or 2, but 6 over 2 simplifies to 3 over 1, or 3. So in my first stretch, in the orange stretch of my journey, I was traveling 2 feet per second, but then I started going faster in the second leg of my trip because now I'm traveling 3 feet in 1 second. So I actually got faster. So whenever your line in a distance time graph does not make a straight line, in other words, when it's not linear, that means that we're not traveling at the same rate the entire time. The last example I'm going to show you is a shape that looks a little something like this. First of all, this is not linear. This is more like 2 straight lines that are kind of made to go together. Linear would be 1 consistent straight line. So I don't have a linear relationship here. So I know that if I am matching up my story graphs, I am not going to match up the story that says they are traveling at a constant rate the entire time. Now let's look at some points and get a little deeper into it. So the same one, you can tell I'm not being very creative. I'm just coming up with the same first coordinate. So I traveled 2 feet in 1 second. I can just tell by looking at the graph. And then I'll just pick a coordinate right here. See where this crosses? On that line right there at the corner. So according to this coordinate, I've traveled for 4 seconds. Oops, that needs to go on the bottom. But I've still only traveled 2 feet. So basically, the time is moving, but I'm not moving. I'm still only 2 feet from home, even after 4 seconds have passed. If I look at another coordinate right here, I've traveled for 6 seconds. I can see that because it matches up right there. But I've still only traveled 2 feet because it is still only sitting across from the 2 along the y-axis. So when you see a straight line on a graph, a horizontal line like this, a lot of kids think that this means you are traveling at the same rate the entire time because it's not going up or down. And that isn't what it means. It means you're not actually going anywhere at all because your time, as you can see, time's still moving. Time is still moving to the right, but you're not moving up on your distance portion of your graph. So whenever you see a flat line like that, it just means that your distance is staying the same. So if I were making up my own story, it would probably be something like, okay, so here I am starting at home. Apparently I went someplace that was 2 feet away from my house, and then I didn't go anywhere after that. I just stayed put. Maybe I'm riding my bike and I got a flat tire or something, but regardless, I went 2 feet away from home, and then I just stayed there. Hopefully these have helped you out with a couple little hints. Now go match up some graphs with some stories.